Hi, this is the first video in the kinematics section. Just a short introduction, basically. And so what do we mean by kinematics? Well, the definitions here: science of motion. That's basically it. It's interestingly from the French cinématique, because that's all to do with moving pictures. So that's kind of where it comes from. So that's what we mean by kinematics. And how do we describe this motion? What are these problems all about? Characteristics of motion. Well, we're talking about problems that relate time, displacement, velocity, and acceleration. So velocity meters per second, acceleration meters per second. You notice these are all metric units that we're sort of used to. There are other ones that we don't actually come into at A level, because there are sort of, time is a sort of usual thing. Displacement meters, velocity is the rate of change of displacement with meters, with respect to time, sorry, meters per second. Acceleration is the rate of change in velocity, meters per second, how much the meters per second changes every second. You might expect that actually we can go further than this. If we can go from meters per second to meters per second, then why not meters per second? Well, in fact, you can, not at A level, but meters per second, which is the rate of change of acceleration, is actually relevant in some areas of mechanics and physics. It's actually called jerk, which sounds a bit of a weird term, but that's what it is. Now, a couple of things we need to bear in mind when we're looking at these kinematics problems, just sort of general things, is that direction is important. So if we're measuring in the rightward direction, we measure something of 20 meters, then that in a sense is a negative 20 meters if we're looking in the leftward direction. So direction is all important, and of course that goes for velocity as well. Cars going down a hill at 30 miles per hour or 30 kilometers per hour, then it's sort of going up the hill at negative 30 kilometers per hour, if you see what I mean. So that's one of the characteristics that we need to be careful about when we're doing these problems. So we need to know which direction is our positive direction, effectively. And the other thing which is sort of springs off that really is the fact that is the difference between displacement and distance. So displacement, after a particle has moved around for a bit, maybe going forwards and backwards, it ends up at a point which has a displacement from the original point. That is displacement. The actual distance it's traveled is how far it's kind of gone in the meantime. So if something was to set off from say where I am now, travel 100 meters away, and then come back partway 50 meters, then the total distance traveled would be 150 meters, but the actual displacement where it's ended up is going to be 50 meters, and that comes quite important in some of the calculations. So so that's about it really. I said it was a short introduction, and those are the kind of the main things to bear in mind. Anyway, we'll go through the actual topics within kinematics in the later videos, so I'll see you then.